All right, now we're going proofs. The whole proof, the proof, the whole proof, and nothing but the proof. All right, we've got four of these to go through. So let's take a look at the first one. Segment AB is perpendicular to segment BC. You're going to have to pause this a lot because I already have these written down. So grab your cheat sheet so that you can spell everything right and fill in the blanks as we go. The first two are definitely given statements because they're there for you. So pause the video, write down your given statements. Step number 3, what do we know about perpendicular segments? We know that they make a right angle, but we have to know the name of that right angle. Angle B is a right angle by the definition of perpendicular. If two segments are perpendicular, then they form a right angle. Definition of perpendicular. But the same also happens for the second pair of perpendicular segments. Here was our first one, here was our second one. So angle C is a right angle, also by definition of perpendicular. If there are two perpendicular givens, you're going to have two definition of perpendicular reasons. From there, we can go right to the proof. If we know angle B is a right angle and angle C is a right angle, then we know that angle B is congruent to angle C because of the right angle congruence theorem. Take a look at cheat sheet 4 so you can write it down properly. If two, that's all we have, angles are right angles, then they are congruent by the right angle congruence theorem. If two angles are right angles, then they are congruent. All right, go back, fill in the spaces, make sure you understand what you're doing on here. Don't go as fast as I am on these notes. Next one, angle A is supplementary to angle B. Angle C is also supplementary to angle B. This looks just like our notes that we did on day 2, however, we're putting it into a full proof. We know that if two angles are supplementary to the same angle, if two angles are supplementary to the same angle, then they are congruent. That becomes our next step. Angle A is congruent to angle C. If two angles are supplementary to the same angle, then they, being the two angles, are congruent by the congruent supplements theorem. But if you go up and look at our proof, they didn't want congruent angles. They wanted equal measures. We can take those same congruent angles and turn them into equal measures. The measure of angle A equals the measure of angle C because of the definition of congruent. If two angles are congruent, then they have the same measure. All right, take your time, write that down. Third proof, angle 1 is complementary to angle 2, but angle 3 is complementary to angle 4. They are not complementary to the same angle. We've got given. Take a look at cheat sheet 4 carefully. If two angles, let me scroll up here, are complementary to congruent angles, then they are congruent. It doesn't say the same angle. If two angles are complementary to congruent angles, well, right now 2 and 4 are not congruent. But look at the diagram. We can make them congruent. How do we make angle 2 and angle 4 congruent? Just say that they are congruent. Angle 2 is congruent to angle 4. How are they possibly congruent? If you look carefully at the diagram, those are called vertical angles. And you have vertical angles also on cheat sheet 4. If two angles are vertical angles, then they are congruent. So by vertical angles. And now that we have if two angles are complementary to congruent angles, then they are congruent. Going back to the two angles, they are congruent by the congruent complements theorem. Comp. We know we're going to use that, but first we had to make those congruent. A nice little 4-step proof. And the last one, given the diagram, we talked about this in section 2.7, day 2 also. If you have a diagram that has a nice straight line, well, first you have to say that you have a diagram because that's all that's given to you. So you have a diagram. Capital or lowercase, doesn't matter. That is given to you. What did we do when we had a diagram? We saw that we had a straight line. Therefore, angle 1 and angle 2 are a linear pair because it says if two angles are a linear pair, then they form a straight line. Definition of linear pair. What do we do when we know that they have a linear pair? Well, we know eventually we have to make them equal to 180, but we can't yet. We have to use linear pair. What does the linear pair postulate say? If two angles form a linear pair, oh, we just did that, then they are supplementary. What are they? They are those two angles. What two angles are supplementary? Angle 1 and angle 2. We have to do what the linear pair postulate tells us. The linear pair postulate tells us if two angles form a linear pair, then they are supplementary by the linear pair postulate. Now we only have one word supplementary. We don't have sup. Just one word supplementary. Go look at cheat sheet 3, and again, pause the video so you can go find it. Cheat sheet 3 says two angles are supplementary if and only if the sum of their measures is 180 degrees. Pause.
Good morning, Rod. This is your...
Right, where do we go from here? Angle 1 and angle 2 are supplementary. We go to cheat sheet 3, which says, cheat sheet 3, if you look at the word supplementary, if two angles are supplementary, then the sum of their measures is 180 degrees. We have to show that the sum of their measures is 180 degrees, just like they wanted us to prove it. Measure of angle 1 plus measure of angle 2 is 180 degrees by the definition of supplementary. 4 proofs, but not too long of steps, and they gave you some hints in between. Good luck.